I'm Ranno. I'm from Telia, and I'm going to give you a little perspective from DevOps side, or as slide says, DevSecOps side. So there is a little bit security also in our DevOps teams, and a little bit of the background, how we work, what we do, also a little bit about me, and also a little about the setup and tips and tricks, and maybe a little also about what we are doing next. So at first me, who I am, what I do. I'm in Telia a little, or maybe a little bit more than a little, 15+ years. So I have a good view what has been, what is now. So I can also show you the roadmap later. I have been always in the dev side. I'm doing development, administration, architecture, databases, code, operating systems, whatever you can name. And it's always been like a good choice for me. I can do this, I can do this, I can switch. So it's a very good place to be for me at the moment. For the business side or the general side from the Telia, I'm in the backends, not in the front. You can't see my fingerprints in the e-shops, in the ordering flows, in the Telia shops. That's not mine. Mine is the backend side where you order something, then something happens, and when something activates or you get some internet from Telia, then there is my playground. And maybe one thing we did a few years ago as a hackathon in Telia, we made a technician app. When you order fixed internet connection, you get technician booking in your home, then you can see the technician picture, you can book the time, change the time. Then that was our thing we did, just from the bottom to the front, a little view. And we also have some UIs, but those are internal, so those are our administrating UIs. So we also keep good security and good manners also in UIs, in the backends. For the teams, Telia is a big company. There are many areas or domains, you name it. So also the teams are, DevOps teams are shared or grouped by those areas, like order capturing for the sales side or self-services. And there are I don't know how many exactly. There are maybe 60 or more teams separately. And in some areas, there are many teams on one application or one area. And I am operations delivery side, doing activation, provisioning, and the technical side. We are doing nowadays in bigger teams also Scrum, Agile, Safe. And our team responsibility is everything. It's not only developing or just analyzing. It's from code to the infrastructure. And the infrastructure can be Kubernetes, it can be VMs or whatever. We can also choose what we do. It can be also like Amazon Cloud services if you need those. And DevOps or SecOps teams are meant to be everywhere. Some of them are partners, some of them are internal, some are in other countries, and etc. So the playground is huge. This should be the theoretical view how our teams should work. It's a safe framework for enterprises. This is the business side, team side, development, etc. It's a full presentations or full day of learning if you want to go deep dive here. But we are on this picture, and for us, it's working, I think, 2 or 3 years already, mainly. And we are extending this to the other countries in Telia, also in Sweden, Norway, Finland. So the framework is, I think it's working, but this is just a picture how we should work in development side. But don't let's go deeper in this because you do your things in here and you don't have to know everything. So why we are the DevSecOps? This because, and this is only the tip of the iceberg here. We have 60+ technologies, frameworks, whatever you can name, what you have to know in like one team. You don't have to know everything, but it's good if you can do everything, so we can replace each other when it's needed. But mostly we start at Python, we code something, and we deploy this. Mostly we use Postgres databases. Usually every team has, because of the history, also Oracle or the legacy part in their responsibilities. Like we are doing new APIs, new platforms, but also everybody gets something from the history, like Oracle or whatever older system. Maybe somebody has some Windows systems, some Perl or whatever older ones. We use Redis for configuration management and some fast caches in application and UI views. For monitoring, we use Prometheus and Grafana mostly. Also some logging monitoring and Jaeger tracing in some applications. And for DevOps side, for containers and applications in VMs, we use Portainer and also some message queues, Rabbit, Kafka. And there are many more, like I had them listed, but the most important ones I think is here. Maybe Solr also for speeding up our queries. And from security side, I think the most important thing is container and configuration scanning tool called Trivi. We implemented just lately. So it's all automatic. You don't have to think it all the time. But when you deploy or build something, then it's scanning and giving you out the results, what's wrong, what's level, is the security risks, is it high, low, and etc. So there's also everywhere is a little bit of security also in our teams. So how it was and how we came here. So at first, I think it was 2007 or something when I joined Telia, when we wanted to build some new applications. Then we had a separate team, and the team has a project manager who ordered the virtual machines then, and dev teams basically only wrote code, and they didn't know much about the underlying infrastructure. Maybe there was something related to Oracle then, and then was some plugins or something you can write a little bit lower levels, but mostly it was like infra teams, project managers. You just think about the names, maybe sometimes other, maybe not the names, you just got something. And it was, it took a long time to get something because there are many teams ordering something. They had like one team and they just queued up but yeah, this was not like the every day there is a new application, but sometimes when you mostly need it, then it took time. Then project managers went away. Then we had only administrators. And then when you want something, you went directly to the admin and ordered your application. And it was a little bit quicker, a little bit simpler for dev teams. And after admins, DevOps came, but there were still virtual machines. But this was not the overnight like jump. It was like mostly teams that can do those tasks and work, and teams who can be like DevOps teams only did this. And we also did automation for those teams. So you had a wizard and click next, and then you get your virtual machines, you put in the names and configurations. So we built these tools by ourselves. So it also took time, but it was a DevOps vibe already there. After that, we moved to the Docker. This was still VMs, but running Docker inside the VM and deployment and environment and everything was in the Docker. So VM was only plain like Linux, CentOS or Debian server running some monitoring tools, some maybe logging tools, depends on what system it was. Database was a little bit different, but and everything application part was in Docker. And this went, I think, long time, but then in 2017, I think it was, we introduced Kubernetes, and then DevOps team got the most simplest tools, like the last slide from the, or the almost last slide from the previous presenter. You just write your YAML file and it's done. So it was something like that. That you can describe your environment, your operating system if you need this specifically, and other libraries, and you can go. You don't have to order something, you don't have to wait anything. So for dev team, it was a very big step and first up. And in our current team, where I'm working in the backend in activation and provisioning team, there is still 50% old systems. The main core systems in Telia is still Oracle because the legacy, there are so much products and services. So it's not like you can do this, but every new thing you do in a new way, like is it in VM? Mostly not anymore, but most, I think maybe 80 or 90% new things go to the Kubernetes. If there is no need for something special like Amazon Cloud or VM, like some out of the self products need some VMs, you cannot set up those in the Kubernetes because you buy a product, you set up as the seller demands. Or there is some other security or whatever reason. So, and 40% our team is doing Kubernetes already. And from Docker to Kubernetes, I think it was like maybe 3 months jump. It was not a big jump because Docker and and if you write your YAML right, then you can do it quickly. It's just you need maybe some scripts, and those maybe today also we wrote our own, but I think today there are more automated things already. So our in-house Kubernetes, little bit what we have, not very deep dive, just in DevOps team's perspective. We are not administrating this. This is Kubernetes is a service for us. It's like we can deploy there, we have some access, but and sometimes we can require some, we need this, maybe we want this operator there or something, but usually it's just what there is we can use. So we also use Docker registry internally. Maybe 50% comes from the Docker hub images, but usually the base images came somewhere from there. And we build our own and then push to the local registry and use those there. So in the kit, you build your code, you build your environment, your images. In CD, continuous delivery, or maybe also in build, you can push those to the registry. And later on, when you're going to deploy the application, you link or just say that the image name is the local or the internal image and push those to the Kubernetes. We also have Estonian Kubernetes clusters, also in other countries have, I think, maybe 4 or 3 Kubernetes clusters separately, but I'm talking only about Estonian because we are not using the other ones at the moment yet. The cluster is active setup. It means that we have 2 physical sites. When one goes down, hopefully other one is up, and it can run forward from there. And active setup is that always you have all the pods and cluster nodes. Everything is also, if you have like deployment where is like, let's say you have one pod that is replicated 8 times, then it's 2 times 8. You have 16 pods then on your cluster setup. So everything is like doubled, and you have to always think about this. If you have something that has to be run in one pod, but you can't run it one pod, you also have to think that this one pod is duplicated to the other active site, and you cannot run it one thread. So let's say if you log something or want to push some event up from the application that something happened, and it's based on the database, then maybe 2 pods pick it up and can then do the doubling. So you have to always be prepared for the multiple events, multiple same events. So let's go a little bit about statistics. It was 2016, not 17. We are using almost not everything, but much of the kinds on the Kubernetes that can have jobs, cron jobs, diamond set, replication set, etc. Today we are not using custom development or the descriptions because this is a central Kubernetes setup, and it's not easy to build something for everyone. So it's usually simplified view. But like, let's say I want to do my own kind about my application, or I want to do my own kind of Prometheus or something, then this platform is not, but not the admin. The admin is not doing this, because he says that if you want this, you build your own VMs and put Kubernetes cluster there, and then you can use Kubernetes, and you can use your own Kubernetes this way if you want so special things there. And some people or some teams usually use those setups also. Like I think 3 or 4 teams set up their own Kubernetes cluster and using their products there. 95% of the applications is Nginx, Java, Spring Boot, Python Pyramid, React, Vue, Angular. So the main and simplest way for those. We don't yet have persistent storage yet. Also, it's done already. Admin says that it's like there, but it's not like published yet. I think maybe this year, maybe next year, we also get the persistent storage also. So today, if you want something like persistent or stored, then you have to push it to the database or have it in the Amazon S3 storage space, or you can push your logs or something in your log server separately. So you have to think about storage always today. You can't set like in YAML that I want this storage space and just use it. Other statistics, we have 2,500 pods running, 1,000 services, like on top of that, 400 namespaces. It's not like every team has its own namespace, but namespace is basically one area, one application area. So like if I'm thinking about provisioning or service, low level handling, then there are maybe like 4 namespaces for that, and so like, or the billing or eShop or something, they could have like many namespaces. As I said, I think there are like 60 or 70 teams. And deployments, 1,400. 4 clusters. It means that 8 clusters, we have like the double the clusters. We also have internal and external clusters. External means you can access it from the outside of the house or the Telia. Internal clusters are only accessible internally, so backend tools. Discovery sites already talked about. This central Kubernetes cluster takes up about 1,100 CPU cores at the peak times, but it's all shared. Like when your application don't need it, then it scales down. It's not using the full. You just say how much it maximally need, and you can use it as resourcefully as you can. We have 6 terabytes of RAM, 30 terabytes of disk space, and this space is only used for local logging and not much, just for some storage you need there. As I said before, the main storage or databases or whatever you want, then you have to outsource them to VMs or the clouds. And we have 100 nodes workers to serve the pods and deployments. As I said, namespaces are in domains. Domains have namespaces, vice versa. And we are using namespaces as a like separation between the application, and also we use tokens to access them. So we don't have like airbag or other authentication accessibility, just the tokens for people. Also the CI/CD has its own tokens, and that's the basic security. And also there is a sandbox for everyone where you can just, if you want something to test out or do some introduction or educational work, then you can use also sandbox. But nowadays it's also easy to set up Kubernetes cluster on your local machine, so Minikube or whatever you want. So sandbox is not so very popular at the moment, but it's good to have if somebody needs this, or he has like not a very good PC or laptop, so it can be used. So about the things we have and what we have set up to do the Kubernetes experience more like simple or simplifying everything or automating everything. So usually when you deploy your application, you need somehow other world or outer world to access it. Like you have to have like address for it or IP or something. So we have load balancers for that, and we have in Telia views big IP F5s. Those are like separate racks or servers in the server rooms, and we have customized those controllers by software. So when you say in your Kubernetes annotation for your deployment or your service that F5 controller provisioning equals true, then this is picked up by this controller in load balancer, and it automatically deploys you the DNS name, the IP, and it's I think in 5 minutes it's accessible for your application. So when you deploy first your application, you just have to set the provisioning true, and you get the access after 5 minutes to your application in the full, like the internal network. Just maybe if you need some firewall accesses or something, then you have to do those beforehand or afterwards if you need some special tunneling. We use SSL internally for between applications and verifications. And yeah, this is usually done manually or something in other ways, or you have to set up your concrete configurations or manually deploy something. But this is very good for dev teams. Before we had also scaling in some applications needed. So when the load was the bigger, like we have once a month for due, we have the customers who don't want to pay us, so we have to send emails or close down some services because the service assurance and billing. And then we just few days we had to scale up our VMs or the setups. But now in Kubernetes, it's much easier. You just in your deployment, you say that how many replicas you need, what's the maximum, and the application or the Kubernetes monitors this on the fly and just scales up. If there's any need for like CPU or RAM or whatever, you can set up there. So it's also easier to auto scale with Kubernetes than it was before. So a little bit about application example I had here, just to quick peek. How is like the application setup? Oh, okay, I think my browser is crashed background. Okay, but I had also some slides, so let's maybe we can go there. So for Python application, what you need, usually you need something to serve your application. It's not like you click something and it runs, but you have to have some background process what serves it. We use it for that USGI. If you go to the previous slide, for the web server side, so it's the serving element for your application. For outer world, you need some web server that routes incoming requests to your application. So we are using Nginx for that. And just simple routing, few lines in Nginx configuration, and also USG configuration and also a few lines. So it's very simple. And this is how we set up our like Python application. And in Kubernetes, it's also simple. You just run up your Docker image and set up those few lines there, and it's already running. And these few lines also starts your application. Of course, your code is a little bit longer, but this is the serving point. For application, you also need some configuration, like your URIs or your passwords, some application runtime environmental configuration, like is it DevTest something like there. So we also wrote our own ini file parsers at the moment. So it was the simplest way at the first. So we are developers there, and if we can see that we can do this at by ourselves, then the first thing is okay, let's do this. And if it's not too complicated and we have time. For deployment and continuous integration, we use Bitbucket and Atlassian stack at the moment. Bamboo is our deployer and builder. Bitbucket is our like code repository. We use those in, I think, 80% of our applications at the moment. Old Oracle ones, and those are manually done already still today. Here we have also some customizations done for config maps and secrets. We use like our own shell scripts to parse the ini files, to decrypt the passwords, encrypt those, and put those to the Kubernetes environment. A little bit Helm usage also in some teams, but not much at the moment. But Bitbucket supports those already, and kubectl also. So the deployment configuration of the config files, those are not very complicated, just maybe 20-30 lines for your, depends on application, but not much. In some applications, or we try to do this in all applications because we don't want big downtimes or be up at the night, so we can do our deployments and everything whenever those are needed, at the downtime or whatever. So zero downtime is needed. And this is also simple on Kubernetes. So it's just, you don't have to do almost anything to do to this. You just deploy your application and the replica sets, and those are just doing the thing. Closing down the old ones and scaling up new ones. And if new ones are healthy, then they are going to kill old ones, and your new app is up and running. And you always have to think about those processes when you develop, so that your code lives up this process. Monitoring in Kubernetes is also simple for dev teams. We just have to describe our graphs and set up the views in Grafana. So we don't have to set any special logging or application events or something if it's not needed especially, but usually you just deploy your application. You say what's your application ID, you describe the labels there and your names for your applications, and then few seconds later you can already configure Grafana graphs and have your reports and alarms and everything set. We also use central configuration management for our applications. When you do your application, every application is registered, and the performers or the administrators, developers, admin users are described there. And then when some alarms are fire up, then the system already knows who is responsible, who to send emails. And we also have Grafana and Slack integration. Daily basis, we are using Slack mostly. So we have separate Slack scanner for every application almost. And if something goes bad, then we get it from the Slack. And it's simple, like you have your Slack in your phone and everywhere. So if you're admin, then it's simple to get. You don't have to mess without emails or SMSs or anything that old anymore. And it's live metrics. It's like few seconds, I think, is the delay mostly. And Grafana and Prometheus is also central, so it's no setup for dev teams. Just looking. This is a simple view. You have your processes, CPUs, whatever, just for demonstration, not anything special to look at. We use logging in sidecar pods, so we use rsyslog mostly. When you set up your deployment, you set one container for rsyslog and set up those configurations there, like Nginx, USKey, application logs there, and then rsyslog takes care of your logging. And we log to the central logging system, so Graylog we are using. And there you can search, you can set alarms there also if you want by the logs. And this is just simple example also how to set it. Maybe there are some tips and tricks if you go deeper, how exactly you configure and what parameters you have to set that your logs are actually arriving at the central system, but that's not described here. There is some bits and bits. It's not like describing only YAML and it works, but a little bit there. So we also have CI/CD platform supporting Kubernetes, like when you build your application or run your tests or whatever you want to do at the building phase with your application. The Bitbucket also, or the Bamboo also supports like plugins. And one plugin there is that you can push your deployments of your like tests or security tests, integration tests to the Kubernetes. Kubernetes runs the tests and sends the results back, or you can pull the results back. So you don't need special environment for your deployment or the CI/CD environment. You can run those in Docker there or in VMs where the deployment is running, but sometimes you need some special, or it's even simpler. You set up your test and everything in the same environment as your development and local environments are. So you own your pipelines and definitions. And you can pick up your environments, tools, and everything there. You don't depend on the central system. So it's also very good for dev teams. And it's also a little bit saves you money, because those build tools and platforms usually is paid by the CPU or RAM count. So if you push your things to the Kubernetes and not using the central system, so you don't have so much license costs there. So it's also money saving bit. UI is for there, something like that. You just pick that I need this per build container, and you pick your image and your like estimation what your workload is, like how many CPUs RAM you need, and you just save. And then everything you do in your CI/CD goes through this process. So it's also easy to set up. For development teams or just programming side, it's also good. Teams can download and use the same image as a local environment or the live environment and use those. And the bad side is that you have to learn something, but for developers, usually it's a good thing, because they are hungry for new things and want to learn everything. So it depends on the people, but usually it's good. But when you can do something new, you can plan your databases. You have to plan your databases changes in 3 steps as usual. If you have many node application, Kubernetes is the same thing, where you like deploy your new code where that supports the new database change. Then you change your database, and then you remove your old code, and many steps there for like critical database changes. Testing is also a simplifier. For if you have some live bug, you can switch the branch very easily, or the image on the Kubernetes very easily. So you just set your image pull policy always at first, and then when you want to change your branch, like in dev environment or test environment, then you just with one command you can change the image there and test your workflows, and then quickly back if it's not needed anymore. And testing is also like more bulletproof. Dev test live, everything is in the same environment. You use the same like the code to deploy the infrastructure. So testing is also better like it was before, when VMs there was different versions, VMs and etc. So in Kubernetes you can keep, and also the housekeeping is much simpler. You can just change one file and everything is the same everywhere. So a little bit about next steps. From here, we are changing our Bitbucket platform or the Bamboo Atlassian stack CI/CD to the GitHub. It's mostly organizational decision. It's not like we had some bad experiences or something, but we are moving to the GitHub in the whole Telia organization over the country. So those are just formal things to do. Migrating legacy. As I said before, we have 50% still in the legacy and only 40% in the Kubernetes. So we are doing those. Hope to use more Helm to get rid of the automation or the shell scripts we wrote by ourselves, or the ini parsers. Maybe we can simplify those by Helm and maybe some those tools. Use more Helm and Ingress also. Today we are not using Ingress, only the services, but we are seeing benefits also there to route the application in the same, in one application, many routes in the different spots maybe, and some those situations. And we also try to use Minikube and Kubernetes cluster locally more and more. So I personally use Rancher desktop because I'm using Windows at the moment mostly. Some Linux work also, but not much there. Some use Docker desktop, and who is on Linux, so I think some use Minikube at the most. And so why locally? Because we want to just be in the same environment, do some same things as your live environment is, because we are also admins and DevOps. So when you do everything the same always and everywhere, then it's much faster and simple in the sum. And so that was it. Thanks. Yeah, it's virtualized virtual machines, but where you like house, but yeah, there are some hardware also, but in clusters are in VMs in general. The question was about the history about installing the Kubernetes on the bare metal, but I don't know the story because we are not admins, we are just DevOps and using the platform. But I think the bare metal one, maybe those was the first attempts, because nowadays is everything bare metal is somewhere deep, and Kubernetes is on VM, so that's not the problem today. And the question was how we keep in sync the active cluster. It's done automatically by Kubernetes, so we don't have to do it by ourselves. You just set up your Kubernetes and it does your thing. The question was how we prevent over provisioning. Today, it's not done automatically somehow. Today, we know how much everybody describes their in their deployment and service deployment manifest, how much CPU they need and what's the min and max. And then administrators look those statistics, and if there is a strict upline so in the graphics, so the administration react to those. So this is not like we don't do any automatic provisioning for the platform or in Kubernetes. Just monitoring, I think, is the answer. Yeah, the question was, do we read our Trivi reports? Yeah, we have like Trivi running automatically on every build or your branch in Git like commit. And we don't look at every commit to those reports, but we like monthly or quarterly look those reports, summarize them, and look the next steps from there. Yeah, we have dev, test, and production environments. And for your application, you keep your dev, test, and live branches or the forks there. And when you need some special cases, like you develop your special /10 branch thing, then you can push it freely into those branches. So it's not so critical that every time in dev and test environment, everybody is like interacting and testing the system. So you can freely like for a few hours or something, or a few days in some cases, you can just push your branch there and do your testing. So if you're not changing the world, like the vice versa, like you're changing the APIs, or it's just little things. The question was how we sync the changes. It's just communication. If you know those changes are depend or change or impact others, then you just call them and sync those. So you have to know how much you change and how much it impacts.